Chapter 9, Engine Housing Components. This chapter will identify engine housing components on commercial diesels, identify cylinder blocks used in current diesel engines, outline procedures to inspect a cylinder block, measure a engine cylinder block to specs using service literature, identify the types of liners used in diesel engines, explain the procedures to remove dry, wet, and mid-stop liners, describe the process required to remove a seized liner from a block bore. Perform selective fitting of a set of dry liners to a cylinder block. Explain how cavitation erosion occurs on wet liners. Identify the type of cylinder heads used in diesel engines. Describe component parts of a cylinder head. Define component, creep, and gasket yield. Explain procedure to measure and test reconditioned cylinder heads. Describe the roles of intake and exhaust manifolds, describe the function of the oil pan in the engine, and determine the types of oil pan failures that may be repairable by welding. Engine housing components are those components that enclose the internal engine components: engine cylinder block and cylinder liners, cylinder head assemblies, intake and exhaust manifolds, and oil pans. Cylinder block is a frame on the engine around which all the other components are assembled in such the same way that subcomponents are assembled around a truck frame. Here's a Navistar compacted graphite iron, which is lighter than gray cast iron. It's a common block material in the last 20 years or so. Typical forces a cylinder block has to sustain: torque twist. There's always a torsional load on the block. The block will always have some twist. The cylinder pressures that exceed 3,500 psi, and the thermal shock of all the heat that's transferring through the block to the various cooling and heat transfer mechanisms. Brace plate, also known as a ladder, bolted to the cylinder block lower flange to add rigidity. Buttress screws, bolts threaded transversely to the cylinder block into the main bearing caps. A cast oil pan with high section modulus bolts onto cylinder block, crankcase flange, and onto the flywheel housing. Cast iron oil pans are becoming less common because of the weight considerations that OEMs and engine manufacturers have to consider. Here's a cylinder block. You got a turbo mounting pad in the back. We have a governor rear bore here, coolant inlet, main oil galleries, camshaft bore, front main bearing cap here, oil pump recess, oil relief valve bore, oil regulator, coolant inlet, and cylinder bore. Incorporates the bores for the piston assemblies, the main bearing bores to mount the crankshaft, coolant passages, water jackets, lubricant passes, drillings, also known as oil galleries, and mounting locations for all the other engine components. Types of blocks used in commercial diesel engines: integral cylinder bore or parent bore. There is no liners in these. Cladded liner, parent bore, wet sleeve liner, dry sleeve liner. Now, wet sleeves or wet liners are common in the heavier duty, some medium, and all heavy duty have wet liners. Dry sleeve liners are used in medium duty, and combination wet dry liners are used in medium duty and in some compressed natural gas Cummins Westport engines. A parent bore is lower initial cost. There's no liner O-rings to fail and no liner protrusion specs to adhere to on reassembly. That is some savings. But dry liners are thin wall sleeves than a wet liner. They are installed on a block usually with a marginally loose fit and retained by the cylinder head. Dry liners do not transfer heat as well as a wet liner, so dry liners are easily removed but oftentimes require a mechanical puller to remove them, and in severe cases they go to a machine shop and they just use a boring bar to actually cut them out. Wet dry sleeves are designed. The hottest part of the liner at the top is in direct contact with the coolant in the water jacket, and the lower portion fits directly onto the cylinder block with a fractional looser interference fit. Consequently, the upper portion in direct contact with the water jacket must have considerable more mass because it has to contain the cylinder, the combustion pressures, and also the heat effect from combustion. Wet dry liners are usually required to seal the water jacket with O-rings. This is a typical wet-dry liner. Sealing a wet liner has an O-ring in a mid-stop, and it has a crevice seal in the groove at the top that points towards the cylinder liner block and lubricated with ethyl glycol. Wet liners transfer heat efficiently into the coolant and are easily replaced at overhaul. This is the most common configuration in heavy truck diesel engines. Cavitation is caused by vapor bubble implosion, or the bursting of the bubbles shortens the life of the wet liners, and it's seldom a problem if the coolant chemistry is properly monitored. Cavitation was a severe condition until always developed coolant that is a premix, and it has all of the components that used to be additives, and now they're completely sold in the coolant, so there's no need for any extended coolant additives. So those days are pretty well gone with today's coolant chemistry. Well, here's a wet liner showing the oil ring, and the top of the liner is going to have the coolant flowing past it, and the bottom is going to be protruding into the crankcase, and it will have oil at the bottom end. Cylinder pressures up to 3,000 psi. Walls expand into coolant, creating a bubble. The bubble collapses 17 times per second at 2,000 RPMs and up to 60,000 psi. And when you have that bubble collapse at 60,000 psi, you have erosion of metal. Wet liner components. This style is showing a mid-stop that has the stop for the liner in the middle of the block. There's shims and O-rings at the bottom, and they're showing a crevice seal up at the top. Removing pistons from cylinder liners can be made easier by removing the carbon ridge that builds up at the top of the ring belt sweep. That's the highest point that the rings travel. The carbon in the wear ridge can be removed with a flexible knife blade followed by a gentle use of emery cloth. Note, some engines, the piston cannot be drawn through the liner board during disassembly. These may require removal of the piston liner and liner as an assembly, as in some off-highway engines require the removal of the crankshaft, and they come out through the bottom. Pulling a liner, we're going to be doing this with a very simple tool. It's going to have a plate that grabs the bottom lip of the liner. It has a platform that has a large threaded bolt, and we're going to be using tools to pull the liners out of the block. Selective fitting of liners to block bores is a good practice whether or not the bore has been machined. To selective fit a group of liners, measure the inside diameter of each block bore across the north, south, east, west faces and grade in order of size. So you have to measure on two axes, a longitudinal and a 90-degree angle perpendicular axis. Next, get a set of new liners and measure the outside diameter of each. Once again, grading in order of size. Now, with today's manufacturing processes, manufacturers can easily hold 4 decimal places. So measuring the liners would be a good practice if you were doing a Cummins 15-liter, because there are 2 different liners that are out there, 152 and 150 millimeter outside diameters. When you fit the liner with the largest outside diameter to the block bore with the largest inside diameter, and so on down in sequence, this practice is not as prevalent today because of the manufacturing processes have been improved. Serviceability checks. You strip the block, you clean scaling, you check for erosion, and you magnaflux the block for cracks in the wear points. We'll get into that in shop. Deck warpage. A typical deck warpage using a straight edge and a thickness or feeler gauge is typically in the area of 3 to 4 thousandths. But always want to check OEM tolerances here, because as manufacturing changes, models can change, and so can specifications. So you always consult the service literature for that exact engine. Main bearing bore check. Main bearing and bore alignment. Check the engine service history to ensure the engine has not been previously line bored. That is, without the bearings in, the main bearing caps are installed, and a machine shop will run a boring bar through there, through all 7 of the caps, and make sure that they're perfectly plumb square and correct inside diameters. Block inspection. Sleeve counterbore to the correct depth. Counterbore depth should typically not vary more than 1/1000th of an inch. Counterbore depth can be subtracted from the sleeve flange dimension to calculate sleeve protrusion. Liner protrusion dimensions may be set by shim plates, or liner selective flange depth. When counterbores have to be recut, ensure that the OEM recommended tools are used and the counterbores are shimmed to specification. Typically, when you are using a cutting tool to cut the mid-stop or the top stop of a block bore, you have to only remove 1.5 thousandths at a time, and use a depth gauge to make sure that you're following the manufacturer's recommendation, because you'll probably have 1 or 2 dimensions that you can meet. If you exceed the deepest one with the most material removal, the block will no longer be serviceable. Installing counterbore shims on a Navstar engine. Here they're showing a mid-stop. It's approximately halfway down the block, and they got a protrusion of 2 to 5 thousandths of an inch, and there is a calculation that the maximum allowable here is going to be based on the shim thickness. So there's a shimming dimension, and there's also a cutting dimension that you have to pay attention to. The manufacturer will call that out in detail in the service literature for that block. Block inspection. Cam bushing. Bore checks. The bore diameter for the cam is installed cam bushings with the correct cam bushing installation equipment. Use drivers with great care, as the bushings may easily be damaged. They ensure that the oil holes are lined up before driving each bushing home. There's a way of marking the location, so you can index the bearing edge and set it on the tool on an index or mark with a paint marker, and you can make sure that you have alignment to the oil holes, which are part of the oil galleries that lubricate the camshaft. Okay, gallery and expansion plug. The gallery and expansion plugs, these are often interface sealed with silicone, thread sealant, or other commercial sealants. That will be called out by the OEM. They will specify exactly what sealant will go into the expansion plug. They're also known as Welch plugs and freeze-out plugs, but that you have to consult the service literature for that exact engine. Cap plug location and installation. Here we're showing where the caps and the locations are, and they have they're showing 1.5 inch cup plug on this particular installation here. Cylinder head seals the engine cylinders and manage cylinder head breathing in diesel application. They're usually cast iron assemblies machined with breathing tracks, ports, cooling and lubrication circuit manifolds, fuel manifolds, and injector bores. Okay, we have multi-cylinder head single slab castings. That's common in today's 6-cylinder trucks. Multiple cylinder head multiple cast units are rare. They're on older engines like the Cummins big cams and the N14. And single cylinder head units are commonly found on much larger diesels in the 12 and 16 cylinder configurations. 16 cylinder, you'll see very common to have a single cylinder head per cylinder. That is for an ease of service. Okay, cutaway of a cylinder head. Here we're showing the core plugs, valve bridges, so that we can activate one rocker will activate 2 valves, the rocker shafts, rocker assembly pedestal, injector pressure inlet tube. This is going through the cylinder head and connects to the high pressure common rail, a hydraulic injector, and intake ports. Cylinder head inspection. You remove the valves, you clean the head. Cylinder head height has to be checked on a flat surface. You have to dress the gasket surface carefully. Some manufacturers do not allow any material removal with compacted graphite iron blocks, so you have to be careful and make sure you have the service literature, because manufacturers, especially the PACCAR MX-11 and MX-13, there's absolutely no material removed from the cylinder head. Magnaflux for cracks, pressure test for leaks. When your testing will has to be done at an ambient temperature of at least 120 degrees. Inspect or replace injector sleeves. These have coolant on the outside. Those can be easily pressurized, and check for any leak down. Check for flatness or warpage. Measure valve guide bores. Ream new valve guides. Inspect valve seats. Install new guide sets. Recondition valves, inspect valve springs, and inspect valve rotators. Valve rotators will move the valve slightly with every activation so that there is a clean contact between the valve face and the valve seat, preventing carbon buildup. So valve rotators are a good feature for valve longevity. Component creep. Most head gaskets require no applied sealant. In fact, may fail if sealants are used. Creep is the relative movement of the clamped engine components due to different coefficients of heat expansion or different mass. There are some fire rings in most of our diesel engines, but some engines like the Navstar Max Force and the PACCAR MX-11 and MX-13, there is no fire ring in the cylinder head gasket, so it's using a lip that's on the deck and the cylinder head to bond together. So there are different technologies that have done away with most of the component creep that is traditionally happens between the cylinder head and the engine deck and the gaskets. Tech tip: installing a cylinder head onto an engine can be made easier by using guide studs inserted into the cylinder bore bolts. These reduce the chances of cylinder gasket misalignment during installation of cylinder head. We typically will install them offset on the ends of the cylinder head. They would be bolts with no heads on them, and they would allow us to set the cylinder head an inch or two above the deck and make sure that we're not scrubbing the gasket as we install the cylinder head. So those are definitely required if you are doing a cylinder head install. Cylinder head torque sequences typically start on the inside. We're showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you're typically starting on the inside and then you're circling your way around to the outside. Okay, intake manifolds in current engines are required to deliver both air and recirculated exhaust gas, EGR, into the engine cylinders. There's several takeoffs there with how the EGR is metered into the intake manifold. Each manufacturer has their own method of controlling the amount of EGR cut that goes into the, or ratio that goes into the intake side of the engine. Exhaust manifolds function to collect cylinder gas and gases and deliver them to the turbo, or in case of naturally aspirated engines, directly to the exhaust piping. Any leaks in the exhaust manifold will affect the operation and the temperatures necessary for exhaust aftertreatment. So we have to pay particular attention on engines that are produced in the last 12 years that have exhaust aftertreatment, because exhaust gas leaks are critical to the function and the temperatures required for the correct operation of our exhaust aftertreatment. Oil pans or sumps, reservoir located in the base of the engine cylinder block. Crankshaft oil pans are manufactured from cast aluminum, stamped mild steel, laminated steels, and various plastics and synthetic fibers. Most of the manufacturers are using composite materials in the last 10 years. Oil pan acts as the reservoir used to collect lubrication oil that gravity causes to drain in the crankcase, which oil pump pickup can recycle it through the lubrication circuit. Oil pan also plays a role in dissipating lube oil heat, that's heat transfer, to the atmosphere. Okay, here's the oil sump oil pan. Here's a front view with the dipstick tube, and here's your oil pickup, which is a screen pickup, and this particular engine looks like it has a gear-driven gear oil pump. Welding oil pans. Not a good practice anymore. We're finding that very few oil pans are weldable. So as composite materials takes over the cast or sheet metal, oil pans are on much older engines. You're not going to see welding as a common practice in shops for repairing oil pans. Okay, tech tip: pneumatic gasket scraper is a great way to move gasket residue from engine block pan flange. Care must be taken to avoid gouging and mating surfaces Some pneumatic scrapers can be aggressive, therefore using pneumatic scrapers on aluminum, glass fiber, carbon oil pans is not allowed. Also, compacted graphite iron, some manufacturers do not allow the use of any scrapers or anything that could possibly have impact to the surfaces of the compacted graphite block. Bolted to the rear, a flywheel housing bolted to the rear of the engine, stationary coupling between engine and transmission, and it has a categorization by the SAE, Society of Automotive Engineers. Okay, flywheel housing on a Mack MP8. Summary: engine cylinder block can be considered the main frame of an engine component to which all others are attached. Heavy-duty engine cylinder blocks are manufactured from gray cast iron on older engines, and modern engines are using compacted graphite iron. Some light-duty diesel engines are using cast aluminum alloy cylinder blocks, often with bores cladded with the PTWA process or with just a straight dry liner, and you will see that in your small six-cylinder medium-duty trucks. Commercial diesel engines using wet dry or wet dry liners make overhaul easier, faster, and extended engine life. Essentially, you buy a kit. If you need 6, you're going to get 6 liners, 6 pistons, and 6 connecting rods. You have to send in 6 connecting rods as cores, and you're going to get a gasket kit with all the O-rings, gaskets, etc. that you're going to need. Some small and medium bore diesels use parent bores. Our Cummins 6.7 and our 5.9s is a parent bore, so there is very little repair that you can do after you have a few thousandths of cylinder wear or any damage to the block. Dry liners are fitted into cylinder block fractionally loose with a fractional interference fit. Dry liners do not transfer heat well from engine cylinder coolant in the water jack as effectively as wet liners. Okay, fitting dry liners to cylinder block bores ensures the best liner to bore fit. That process is not as prevalent today as manufacturing processes have improved to extremely consistent tolerances. Wet liners transfer heat to water jacket efficiently because they're surrounded by coolant. However, they must also support combustion pressures. That's where we get cavitation, when the bubbles burst from the actual combustion event. Wet liners must seal the water jackets using O-rings. Liners are clamped into position by the cylinder head. Therefore, the protrusion of the liner flanges and those dimensions are critical, and they're spelled out very specifically from manufacturer to manufacturer. Typically, your Cummins ISX was between 9 and 11 thousandths, and your PACCAR MX-11 and MX-13 are typically 3 to 4 thousandths. So they have to be done according to manufacturer specifications. Liner protrusion is set by shimming the counterbore selective spec liner flanges. Engine cylinder block should be boiled in a tank. Now, typically that's done in a specialty tank using a caustic soda hot tank. It's generally not done in shops. It's done in specialty shops, and they have the measuring equipment that's using lasers, and they're measuring in millionths, and they're doing Magnaflux. If you're doing an in-frame, you can certainly use Magnaflux and check flatness. The cylinder head houses valve train assemblies, injectors, and engine breathing passages, both intake and exhaust. Engine cylinder blocks should be pressure tested hydrostatically by first heating with hot water. Common locations for cracks are injector bore tubes and valve seats. Cylinder heads must be torqued in sequence to ensure even clamping pressures to the engine deck. Torque cylinder heads in increments is designed to achieve the cylinder head gasket yield point evenly while achieving the required clamping force. Typically, cylinder heads are torqued in 3 sequences. Cylinder head bolts should be lightly lubed with engine oil before installation. Consult manufacturer specifications on this. Some used to be soaked and just dripped. Some have to be soaked, cleaned, and air dried. So there are some differences between manufacturers' intent on what they want done with their head bolts. Also, head bolts, if they're being reused, they may have a stretch limit. So the manufacturer may call out that there is a length that is a go, no-go on your cylinder head bolts. So make sure you check your manufacturer specifications. Most truck diesel engines use the term attuned to describe the exhaust manifolds. They're to feed the turbine housing of the turbocharger. This way, gases move through the manifold is critical for scavenging end gases, but also creating boost for the turbocharger. And also, our exhaust gas creates heat to make the after treatment work. So there's any concerns in the exhaust will affect the exhaust after treatment. Gaskets used to seal the engine components must be able to accommodate dynamic creep without failing. For this reason, gaskets are always single-use items along with O-rings.